In this lecture, we're going to modify our box container and make it support input iterators. And at the end, the goal is to make it work with a few of the built-in algorithms we have in the STL. We want it to work with the find algorithm, and we want it to work with range-based for loops. This is the goal in this lecture here. Please remember the requirement for your container and iterators that you provide. The container needs to be a class template. We already satisfied this requirement because box container is already a class template. And what we want to do is to model iterator types in our class. And we're going to provide the begin and end methods that are going to be used by algorithms to work with our iterators. And we're going to make our iterator model the operators needed by the algorithms that we want to play with here. And that's going to be the find algorithm, which is going to be our starting point. We're going to put the needed type aliases in our iterator class to make it recognizable by the STL. And to be exact, we're going to set up an iterator class, which is called iterator. We're going to set it up exactly like this. And we're going to be providing these type aliases expected by the C++ standard library. And after that, we're going to put in the begin and end methods. These methods are just going to return an iterator that we build in place by wrapping around a pointer to the collection that is wrapped around by our box container class. Nothing complicated here. Once we have this infrastructure in place, we're going to provide the operators needed by our iterator. We're going to provide a dereference operator. We're going to provide a pointer access operator. We are going to provide a ++ operator, which is going to be used to navigate through our collection. And we're going to provide an equals operator and a not equals operator, which are used to check when we have reached the end of our collection here. And once we have these in, they are going to work with our find algorithm as we see right here. And this is going to also work with our range-based for loop. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is custom input iterator. We're going to grab our template files pretty quick and put them in place. And we need the box container class. To grab that, I am going to go in a previous chapter where we worked on this. I think the last version is from the class templates chapter. And we're going to grab the one when we set up concepts to constrain our box container class. I am going to grab the header and the CPP file. I think this is going to be enough. Let's copy this and come back to our current lecture, which is in this chapter here. And we are working on custom input iterator. We're going to put the box container class in here. And we are going to crack this open in Visual Studio Code by dragging and dropping here. We're going to have our code. And let's clean up the main CPP file a little bit. We need to include algorithm because we're going to be using a few algorithms. And we need to include box container. Let's put this in. We are also going to include a vector because we're going to be using this to show what we want for our box container. So let's put in an output stream operator, which is going to print our vector. We are going to go in the main function and set up our vector object here. It's going to contain the data here, and we are going to print this out and use this with the find algorithm here, and we're going to try and find if our collection contains an 8. It's going to find it because we have it right here in the first slot. So let's pass this through the compiler to make sure this is working exactly as we want. We're going to use Clang here, but you can use GCC or the compiler from Microsoft. It doesn't really matter. So the build is good. We can bring up a terminal window. We need a terminal window, not to build. So we have our terminal. And if we run, we're going to see that numbers contains 8 and we have our collection printed out here. Nothing complicated. Now, what we want is for this to work even if we are not using std vector, but our own box container class. So what we can do is comment out our vector line here, and we're going to put in a box container object. So let's do this. We're going to say box container of int, and we're going to add data. This is going to be our box one. But the moment we do that, you're going to see that we have a bunch of squiggly lines. std ranges is not going to work. We don't know what this end method is. And if we try to build, we're going to get a bunch of compiler errors. Let's use GCC because it is my favorite compiler. I use it when I can. And we're going to see that this is not going to work. We don't have things that are expected by the find algorithm. And I have to be honest, these errors are not readable, but concepts make this a little bit easier. We see that we have constraints that are not satisfied. And if we sift through this madness here, we're going to have hints on what is needed. For example, we don't have a begin method. We don't have an end method. This is really going to give us hints on what is needed for this to work. And box container doesn't support the needed iterators, and we're going to fix this in a minute. Another thing I want you to see is that except for the find algorithm that we are trying to use here, this is also not going to work with range-based for loops. So for example, if we go down here and put in our code using range-based for loop, and we want to loop through our collection using the syntax here, you're going to see that this is not going to work. Why is this? Let's pass this through the compiler. We're going to use GCC. And again, if we sift through this, you're going to see that we don't have an end method. And somewhere we are also going to see that we don't have a begin method, because the range-based for loop code here is going to expand to code that uses iterators behind the scenes. Let's comment out our box container to show you that this is going to work with vector. So vector has the needed iterators to work with range-based for loops. But at this moment, this is not going to work with our box container class. I really want you to see this. So let's see this world. It's going to work with vector, but we want this to also work with our box container class. So let's go to work and put in the needed iterators. But before we go there, let's turn this back to use our box container. And we're going to see that it works with range-based for loops here. And once we have that, we're going to try this out with our find algorithm and see what we can get. So let's go to box container and revisit it a little bit. It's really nothing complicated. If you watch the chapter on class templates, it's just a class template which happens to be protected using concepts here. And we're going to go in some public scope and provide our iterator class. I think we can go down before we have our box container constructor. I think we can do that. So, or let's see what we can do. I think we can even go before our private section here and provide a public section. And this is where we're going to be putting our iterator class. We're going to say class, and we're going to call that iterator. And it's going to be delimited by these curly braces. We are going to go in the public scope of this class, and we're going to put in the needed type aliases that are needed by the C++ standard library. We're going to put in iterator category, which is going to specify what kind of iterator we want to model here. We want to model an input iterator, so we're going to specify std input iterator tag. You can search for these things in CPP reference, and you're going to have more information. We're going to provide a difference type, which is what we get when we subtract two iterators. Iterator type is going to be whatever our box container is containing, so that's going to be T here. And a pointer type is going to be a pointer to T. Reference type is going to be a reference to T. Nothing complicated here. Once we have this, we're going to provide a private section. Let's do that. And our private section is going to contain a pointer type called mptr. So pointer type is just going to be a pointer to T, as we see right here. Once we have all these things in, we're going to go back in the public scope and provide a bunch of methods that are needed for our iterator to work. We need a default constructor because it's going to be needed somewhere down below in the machinery of the C++ standard library. We need a reference operator, which is going to return whatever is pointed to by our wrapped pointer. We need a pointer access operator, and we need a plus operator. On top of that, we also need equals, and not equals, which are probably going to be used to check when we have reached the end of our collection if we happen to be looping through it using iterators. Now, this is mostly what we need in our iterator class. Once we have this, we will go on the outside of the class here and provide a begin and end method. Now, the begin method is going to return an iterator pointing to the first element in our collection, and that's going to be m items 0. And the end method is going to return an iterator pointing to the element past the last element in the collection, and that's going to be the element at the index M size here. You can check this out. If this is not making sense, you can even draw this on paper. You're going to see that this is going to work. Now, once we have this in, notice that the main CPP file is no longer red. You're going to see that now our range-based for loop is going to work, and this is really cool. Let's pass this through the compiler. We're going to use GCC, and we're going to see that now this is going to build. Notice that we are able to use a range-based for loop with our own container. This is really cool. I can't tell you how excited I was the first time I was able to do this. This is really cool. Let's pass this through. Let's run this and see what we get. We're going to see that this is going to print our collection through a range-based for loop, and this is really cool. We also printed our box container through the output stream operator that is provided by our class, but we can also use a range-based for loop and print this thing, and this is going to work. Now that the range-based for loop is working, I think we can also try our find algorithm and show you that it is working. This is going to be really cool because the find algorithm really needs only to read through our iterator, and that's what we really provide. Let's pass this through the compiler, and it is going to work. The build is good. And again, notice that this is working on our box container class, and this is working because we provide the needed iterators for this to work, and this is really cool. The build is good. Let's clear and run Rooster. We're going to see that numbers does not contain 8, and if we go in, we're going to see that we don't really have an 8 in. Let's take out this breakpoint we put in by error, but if we put in an 8, let's replace this 2 with 8. And we're going to pass this through the compiler again. We're going to use GCC. The build is going to be good. We can clear and run Rooster. You're going to see that numbers now contains 8. And this is really cool. Now, we have this working with the find algorithm. But what if we try to make this work with an algorithm that needs more than we are providing in our iterator class? For example, we can try and use the reverse algorithm. Let's try and do that. We're going to say std ranges reverse, and we're going to specify box1 and our iterator begin, and we're going to say box1 and let's make sure we say box1 here. And we have begin and end methods, but notice that this is not working because we don't really have the operators needed on the iterator that we are providing here. And one of those operators happens to be the minus operator that is needed by the reverse algorithm that we are trying to use here. I think that's the problem. So you're going to see we're going to get a bunch of errors, and we're going to get a few unsatisfied constraints. And down below, you're going to see that we need to satisfy the bidirectional iterator concept here. So that's the problem. We don't really have a minus operator that would make our iterator bidirectional. So even if we are making some progress, our iterator is really not the most powerful iterator we can provide, but this is a good starting point. And this was really the point of this lecture here, getting our box container class to a point where it can be used with the find algorithm and the range-based for loop code here, and we have achieved that. And this is really all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to try and use our box container class with the copy algorithm, which needs an output iterator, and we're going to see how that plays out. Let's pass this through the compiler again to make sure we have no problems here, and I think it is good now. And we are going to stop here in this lecture, and I will see you in the next one.